Okay, sixth graders, it's math time. We're going to finish up reviewing Unit 13, uh, data and statistics, and we got we got about halfway through that review yesterday. And what I'd like to do is pick it up on page 760 today and finish working through these problems. So get your workbooks out, get a pencil, get a piece of paper, and work these problems along with me, because that's really the best way for you to get a sense of the process of these operations. Starting with number 9, on top of page 760, the histogram shows the weekly earnings of part-time workers. What intervals represent the most common weekly earnings? So looking at the histogram, they're in intervals of 10, and that's dollars. We're talking about their earnings here. And the most common would be 321 to 330 and 341 to 350. Going to problem number 10. There you have a dot plot. And it looks like they're going to ask you 4 questions about information in that dot plot. So what are we looking for here? We're looking for a group of randomly selected smartphone users, how many applications they've downloaded onto their phones. So they have a list of them there. It's saying in A that the modes are 37 and 42. And I would say yes to that, in the sense that those two together are 6 different people that have downloaded either 37 or 42 apps. So that would be the most frequent. But the absolute mode that I would choose is also 41, because 41 is the most prevalent with 4 people. But 37 and 42 would probably be the correct answer. 41 I would also accept based on that understanding. Is there a gap between 38 and 40? Yes, there is. There's no data there at all. And it's saying there's a cluster from 41 to 44, and yes, there is a cluster. And it's saying there's a cluster from 35 to 36, and that would be no. No, the cluster is actually 36 to 37. And it's not a very big cluster, but it's a cluster before that gap that occurs in the data. Number 11. Mrs. Gutierrez made a histogram of the birth months of students in her class. Describe the patterns. Now you're going to look at this histogram here. Or I'm sorry, yeah, it is a histogram. You're going to look at this histogram here, and you're going to notice when the data rises, when it stays and drops. It will rise to a point and stop, and then it will go down. So those are the declines in the data. So let's look at what they're asking you to do here. First thing it wants to know if there are any peaks. And the 2 peaks are in May and August. You see there, May and August coming in at 4. 4 on the frequency side of that. So those would be your 2 peaks. Identify any creases across the interval. Well, it increases from January to March. And then it stays the same in April. So it only increases from January to March, stays the same. But then it also increases from April to May. It goes up again. Looking at the right side of that histogram, between October and November, it goes up again. So those would be the increases. Now the decreases, we're looking for places where it goes down. And it does decline from August all the way to October. It's declining. Then October it rises a little bit, but then at the end of November, it declines again between November and December. So you have a decline between August and October, and another decline between November and December. That's how you would interpret those questions on that histogram. Number 12. Ian collected data on the number of children in 13 different families. They want you to draw a dot plot and use it to find the interquartile range. So, let's first of all get our numbers lined up. And this is 13 numbers. I don't want to miss any. There are 2 zeros. So we got 2 zeros. We've got 4 ones. We've got 3 twos. Remember, we got to list every data point. There are 2 threes. A 4. And then an 8. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we got it all there. So now we're going to build a box plot. So the first thing we got to do is find the median. And because it's 13 numbers, if we go to the middle, our median is going to be 2. So let's draw our line. And we're going to go from 0 to 8. All right, there's our number line. And we've determined that that is our median. So our median is 2. Now, what else is it asking us to do? Find the interquartile range and range. Okay, it's asking us to find 2 things, the range and the interquartile range. So in order to find a range, you subtract the smallest number from the largest number. 0 from 8 is 8. So our range will equal 8. Now, we want to know what the range is between the upper and lower quartile. In order to figure the upper and lower quartile, we have to go left and right of the median and figure out the median of those numbers. And over here we've got 0 and 1. So in between 0 and 1 is going to be 0.5. Over here we've got 3, 4, 5, 6, 7, 8, an even amount of numbers again. So we're going to take these 2 numbers, add them together. That's 11. Divide that by 2, and it's 5.5. So we're going to come up here and make a dot at 5.5. So now we can build our box plot. There's our box plot. Now the range, the interquartile range is, the highest point is 5.5. The lowest point is 0.5. So we're going to subtract that. So our interquartile range is going to be 5. That was a pretty good brain tester, but it's just a matter of understanding that range is subtracting the smallest number from the largest number, finding those interquartiles, which are the medians left and right of the median that you determined from your data. Let's look at number 13. 13 looks like one of those questions where you got to make a decision. Gavin wants to move to a county where it rains about 5 inches every month. So there's our first number, 5 inches per month of rain. And so what they've done here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They've collected data for every month, and they say that the mean of that data is 5, and the median is 4.35. Okay, now they've given us that. We don't have to find it. We don't have to work through that data, but if we wanted to, we could. We could figure out what the mean and the median was. The question is, Gavin says that this county would be a good place to move. Do you agree or disagree with that? So now you've got to make a judgment call based on that data. Now when you look across all 12 months, you see that the driest month is 2.9 inches, and the wettest month is 6 inches. So across the range of that, most of the numbers you see there hover right around 4.5 to 5 to about 5.5. So I would say, yeah, that's a pretty good bet that this is a place to live. Now, when you make that kind of decision, it's important to look at the numbers and see how closely clustered those numbers are. If they're way far apart, in other words, if one month they had 0.5 inches, or even a couple of months where it was below an inch or an inch or less, I would say, you know, if that's the case, when it is raining, it's going to be raining 6, 7, 8 inches. That doesn't make it a very good place to be where you want it to average out around 5. But there was only one month that it was around 3 inches, and only one month when it was at 6 inches. So it's a pretty good bet. I wouldn't use the mean, though. I would use the median to make my final decision, because that represents, across the 12 months, a more accurate interpretation of how much rain they're going to get there. So Gavin, go ahead and move. Number 14, you got another data set there. And it shows the number of books that Peyton reads each month, and Peyton says she usually reads 4 books a month. Is that statement misleading? Well, when you look at the data, you got 2 2s, 3 3s, 2, 2, 3, 3, 3, and then you've got a 4, and then an 11. Well, here's the first thing that jumps out at me. The gap between 4 and 11 makes 11 an outlier, and that's going to skew your data. If we took an average of this, we got 11, 15, 18, 21, 24, 26, 28, and that's 7 data points. So she averages 4 books a week. But when you look at the data, truth of the matter is that she really mostly only reads between 2 and 3 books. One month she got real excited about reading and read a whole bunch of books, and that threw everything off. Just out of curiosity, if we take the 11 out of the equation, and oftentimes you'll hear somebody say, throw away the lowest score and the highest score and average it again. And that gives you a more accurate indication. So if we did that, if we threw away with the lowest score and the highest score, we now have 5, 8, 11, 15, and that's divided by 5, and that means a more accurate description of what she reads on average would be like 3 books a month. And it also is, if you build a dot plot, the 3s would be the mode, the most frequently occurring. So for her to claim that she reads 4 books a month is misleading. She really only reads 3 or less. Number 15, now that's a tough one. So we're going to go ahead and work this out step by step, and this one's going to take a little while. We've got a data set, 3 players on a board game. And we got player A, B, and C. A scores are 90 across the board. B scores are 110, 190. And C's scores are 95, 195. All right. So there are 3 questions down there that you need to indicate whether the statement is correct, true or not. It says the mean absolute deviation of player B's score is 0. The mean absolute deviation, that's the number of points away from the mean. So the first thing we got to do is find the mean, and this is 300 divided by 3. That mean is 100. So on our number line, we go up to 110 from the low point of 90. So this would be my 100. And so we got 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 101, 102, 103, 104, 105, 106, 107, 108, and 109. This is our mean right here at 100. So now we got to figure out what the deviation is. The mean deviation. So our first number is 110. And so from here to 110 is 10. So we got 10. The next number is 100, and it's right there. Don't forget it. We got points here. So from 100 to 100 is 0. Then our next one is 90, which from 100 to 90 is another 10. So we've got 20 divided by 3, which is 6.6. This is what it's going to come out to. Oh, wait a minute, I take that back. Yeah. We'll bring our 0 down. So it's going to be 6.66. So our mean absolute deviation for B is 6.66. That's how many increments it deviates from what our mean, which we determined was 100. What's the next question? The mean absolute deviation of player A's score is 0. And, well, yes, it would be. You can just look at it and know it's 0. Because on that number line, that mean is going to be at 90, because 270 divided by 3 is 90. And the 3 data points above that are all at 90, so that would be 0 plus 0 plus 0 equals 0. In other words, the point doesn't move left or right at all. It just stays right at 90, so it's 0. So we can determine that that is true. Let's get our line back together here. Okay, now, so far we've got 15A, the mean absolute deviation of B score is 0, that's no. The mean absolute deviation of A is 0, that's yes. C, the mean absolute deviation of player B's score is greater than the mean absolute deviation of player C's score. So now we need to find the mean of C. So 95 is 190, so that's 290 divided by 3. And that's going to be 9, right? 3 times 9 is 27. And now we're back to this. So 3 goes into 20 6 times. 6 is 18. And we're back into 20, so 96.6. So the mean of C is going to be 96.6. All right. So we're going to make that 96.6. Now we got to figure out left and right of that, how many points. So it goes from 96.6 to 95. So it goes from here to here. And so you want to take 96.5, subtract 95 from it, and it's 1.5. So we got 1.5 plus the next number is 100, and we're going to go from here to 100. So it's 96.6. Let's take 100 and subtract 96.6 from that. 6 from 10 is 4. 6 from 9 is 3. So that's 3.4. And then the next number again is 95, so we're going to add another 1.5. So altogether we've got 3 plus 3.4, this equals 6.4. And so that's 6.4 divided by 3. Goes in there 2, that's 6. Bring down to 0.4. 3 goes into 4 once. Add a 0. 3 goes into 10, 3. So we got a mean deviation here of 2.13. Now what's it asking us? The mean absolute deviation of player B is greater than the mean absolute deviation of player C. And 6.66 is greater than 2.13. So you would answer C, yes. All right, hopefully you have a pretty good sense of what this stuff's all about. And again, you know, it's not the kind of thing you use every day, but we're always surrounded by data, and having some kind of general understanding of what it is, what it means, and how we can use it to make some kind of determination that has some value to us is the reason why we learn this stuff. That wraps up our math book. We're done. We're done with math now. I encourage you to work these problems. You know, get your brain involved and your hand involved in figuring out the operations required to find and understand these terms. Review the vocabulary so that you know what they mean and how to determine those answers. At any rate, I'll be focusing now mostly on the 4th grade math, so you're going to get a break now. Enjoy life without math class. Take care of yourselves. Stay safe. Always be kind, okay? And we'll see you guys soon.